This video, we are looking at the next conic section, which is ellipses, right? So, same three slides you saw yesterday. What are conic sections? Well, they come from this hourglass shape, and there's four different shapes I can get from slicing it. So these kind of show how I kind of slice it four different ways. And this is a better picture showing each shape that's made. So yesterday we looked at circles. That would be slicing my hourglass perfectly horizontally. If I slice it a little bit at an angle, we get this shape that we're going to look at today called an ellipse. Now, I know this shape right here you're looking at and you're saying, oh, that's an oval. Oval. But in math, there is no such thing as the word oval. It's a made-up word made up by kindergarten teachers because in kindergarten, you, like every other kindergartner, speak with a lisp. And when you speak with a lisp, you cannot pronounce words that rhyme with lisp, like ellipse. I know those don't actually rhyme, but that's the closest a math teacher gets to rhyme. And yeah, so that's why they changed the word ellipse to oval. It's a lot easier to say. But the shape technically is an ellipse. Now, a circle is made from having one point in the middle, and you just kind of draw an arc around that one point in the middle, and you keep this distance the same. An ellipse, on the other hand, has 2 points. And we call them each individually, they're a focus point, and together we call them the foci, all right? And the best way to explain this is my picture here. If I had 2 thumbtacks, had a string attached to each one, and I kind of put a pencil and kind of pulled that string tight, I'd keep going around and I could make my ellipse, all right? Now, as I move around and get one closer, I get closer to one pin or the other, but the length of that string stays the same. So for instance, let's say that my string right here, we got 5 centimeters of string here and 5 centimeters of string here. Well, as my pencil moves, let's say my pencil moves over here. Well, this point would only be, maybe we'll go 2 centimeters from this one. Well, if it's only 2 centimeters from that one, well, the string has to stay the same. So 2 plus what makes 10? Well, this would be 8 centimeters. Okay, that's the original string was 5 and 5, it made 10 centimeters. I moved over here. So the point being that anywhere on the outside of my ellipse, if I add the distance from that point to the 2 focus points, it's always going to give me the same number. Not necessarily 10 times that. All right, well, this is our overwhelming slide that, don't worry, you don't have to copy down, but it explains where all those things on your formula sheet mean. So you're going to have to see pretty much all these words on your formula sheet. Now, this is specifically a horizontal ellipse. Okay, you'll notice on your formula sheet you have horizontal and vertical ellipses. This one's horizontal. See, it's wider than it is tall. If it was a vertical ellipse, it would be taller than it is wide. If it was vertical, then the vertex and the focus would be going up and down, and the covertex would be on the left and right of those points. Still got our center in the middle. Okay. So let's see how we actually can do some problems with these. Now, I'm not actually going to start with problem for one. I'm going to skip all the way down to problem number 5. There'll be a somewhat good reason for why I do that, but we'll go back. We'll come back and get them more specific. So we're going to skip to problem number 5. First step I need to do is figure out where am I at on my formula sheet. Well, I know I'm on the list, so I'm somewhere in this box. But we need to be more specific than that. I need to figure out, am I in the vertical box or am I in the horizontal box? Which one am I dealing with? Well, let's see what they give us. So they give us vertices right here. So I'm going to look at the vertices row. And notice that if I'm in vertical, I have a plus or minus in the Y spot. And if it's horizontal, I have a plus or minus in the X spot. So let's look at my values. Where do I see either a plus or minus, or where do I see a value that's changing? Well, my x value is staying the same. It's just -3. But my y value has a plus or a minus. So it's the y value for vertices that's changing. And so if it's the y value that changes, then that means I must be in the vertical box. So we're only looking at the vertical one because of that. There. Okay. Now, right off the bat, maybe you're saying, wait, that says co-vertices right there. We saw it on the picture, and yet I do not see co-vertices on the formula sheet. You would be correct. And I don't have a really good reason for why it's not on your formula sheet, but you're going to add it right now. So you're going to add this right here. It's going to be right in between ellipses and hyperbola, and we're adding it in between those because it's going to be the same formula for both. All right. So you're going to write co-vertices. Okay. On there. Come down, put a little line there. Now, our co-vertices are going to be the opposite of vertices. So where vertices in vertical have the plus or minus in the y, we're going to put a plus or minus in the x. And co-vertices use the letter B. So you might notice A right there. There's a C right there. And you're like, well, where's the B come from? Well, it comes from the co-vertices. So H plus or minus B, comma, K. Or if I come over here to horizontal, it's going to be H, comma, K plus or minus B. All right. So write those formulas in right there on your formula sheet. All right. So that means we can look at my information up here and figure out all those letters. So if I look at my coordinate points, I see a lot of square roots and plus or minus, and that scares people sometimes, but that actually makes this way easier. We'll get to see points that we know are look nice, pretty whole numbers. Like for instance, we might see -3, 2, and -3, 7. That's actually much harder because now I have to figure out, well, okay, what two things added to make 2, but or added to make 7 and subtracted to make 2. Whereas when they're just plus or minus square roots, it makes it much easier to figure out what my numbers are. So let's look at my vertices. All right, again, we're right here. This has to be the H. That has to be the K. There's my H, there's my K. And then I see plus or minus square root of 15. Well, here it says plus or minus A, so that square root of 15 has to be A. All right. Now, I know you so don't know what A is, but we'll get there. We'll get to that one. We're going to do the same thing for co-vertices. Co-vertices says H plus or minus B. So there's H plus, that must be B. There's H plus or minus B. And then that last number, the -2, has to be the K. Well, we already found H and K in the top, and it's the same as the H and K at the bottom, so that's good. But now we have everything we need to plug into our final answer. So our final answer is going to look like that. That's what we're plugging in. Let's see. X minus H squared over B squared plus Y minus K squared over A squared. And it always equals 1. Now, one thing you need to know is that A for ellipses, this is for only ellipses, A is always bigger than B, right? Only for ellipses, A is always bigger than B. So if it's vertical, A is underneath the Y. If it's horizontal, A is underneath the X. That kind of makes sense. X is horizontal, Y is vertical. So now we're just going to plug in our numbers. We're going to leave X and Y alone. We're just going to plug in for everything else. So X minus, what is H? H is -3. So I'm just going to plus 3. Right? Y minus, what is K? K is -2. 2. So we're going to put plus 2. So we're going to opposite signs, just like we did yesterday with circles. And then in the bottom, I'm going to put b squared and a squared. Well, what's b squared? Well, b is square root of 5. So if I square that, I get 5. And underneath the y, I need a squared. Well, a is square root of 15. So right here, I'm going to put 15. And that is my answer. All right. If you're feeling confident, I doubt it, but if you're feeling confident, you can try to beat me to the answer to number 6. All right. Now, number 6, you'll notice has nice, pretty whole numbers, which makes this more difficult. Not impossible, not even really difficult, but just more difficult than the third. Okay. So, first thing I need to do is figure out, is it vertical or is it horizontal? So I'm going to look at my vertices and I'm saying which values changing. Well, notice that my x values are 2 and negative 10. My y values are 9 and 9. One of those values is changing. One of those values is not changing. Which one's changing? Well, the x value is changing. If the x value is changing, then it's got to be horizontal. Well, for vertices, my equation has the x value changing under horizontal, not vertical. So I know this one has to be horizontal. All right, so I know it's horizontal. What do I do from there? Well, let's figure out which values are not changing. So up there, the 9. You see how the 9 is not changing? Well, that tells me the k. I know 9 has to be k. Okay. Well, let's go down to my covertices because covertices are backwards. You see, for covertices, the x values not changing, which means that has to be my h. So that means I already know the center. I already know the center is h negative 4, comma 9. Don't get them backwards. I know we did the 9 first, but 9 is in the y spot, so it stays in the y spot. Negative 4 is in the x spot, so it stays in the x. Right, so there's the center. That means I already know a lot of my final answer. So we're horizontal, so this is our final answer, what we're going to write. So I'm just going to write it out. I have x minus h. Well, my h is negative 4, so plus 4. I have 1 minus, well, that is 9. 1. So I've already found most of my final answer. I just need to get the bottom part, right? So I know that the a is going to go under the x, and the b has to go under the y, because I'm looking at my formula there. So let's figure out what a and b are. I'm going to move lots of stuff. So a is whatever I'm adding to k to get, oh, excuse me, back up. A, I'll read my formula sheet right here, is whatever I'm adding to h to get 2 and negative 10, okay? Well, I know that h is negative 4. We found that already. So negative 4 plus a has to give me the bigger number, and negative 4 minus a has to give me the smaller number, okay? Or the easier way of thinking about it is how far is negative 4 from 2 and negative 10? How many units? Well, let's just do a number line. I have negative 4, right? Negative 4, negative 4, negative 5, equals 6, go the wrong direction. Negative 5, negative 6, negative 7, negative 8, 9, negative 10. There we go. How many spaces? 1, 2, 3, 4, 5, 6 spaces. Now, I don't even have to do it both ways. Let's do it one or the other. So there's negative 4, negative 3, 1, 2, 3, 4, 5, 6 faces. So my A is 6. It's just how far the vertices are from the center, right? A is how far the vertices are from the center, and 6 units. Well, I know that A squared has to go under the X, so if I square 6, I get 36. Okay? Square 6 there to get that one. All right, for covertices, we're going to do exactly the same thing, except we're finding B. We're finding B now. Let me get rid of that. Where is B? Well, I know that my values are 11 and 7, and I know I have to be going from K to get there. K is 9. So I have 9 here, 9. Let's count. Well, I can go 9, 10, 11, or if I go the other way, 9, 8, 7. How far? 1, 2, 2. So there's my B. And if I square that number, I get 4. That's squared. All right. Now, that should not only help you figure out how to do number 7 and 8, but I'm going to go back and look at number 1, and you'll realize that now you actually know how to do numbers 1 through 4 as well. Right. For this one, well, what value is changing? So we're always going to start off with what value is changing? Well, it's the X. The X is changing. So that tells me, oh, it's got to be horizontal. Well, what's not changing? Well, for vertices, it's 0, which has to be equal to K because it's in the Y spot. And for covertices, well, it's also 0, which has to be H. So I know that the center is 0, comma, 0. The center is the origin. Okay? That actually makes things pretty easy because I'll say, oh, well, I know that I'm going from 0 to 5 or negative 5. How far is it from 0 to 5 or negative 5? A has to be 5 units. Likewise, how far is it from 0 to negative 4 or positive 4? Choose our B. Negative 4 from 0 or positive 4 from 0, that's 4 units. So there we go. There's A, there's B, there's H. Okay, here all ready to play. Now, because the top is going to be X minus 0, Y minus 0, what I'm going to do is just say X squared. Y squared. Whenever H or K is 0, I just put X squared or Y squared. In this case, since they're both 0, I mean both of them just X squared, Y squared. We are horizontal, so the A squared is going to go under the X. A is 5, so we'll put 25 here. B is 4, I'll put 16. And there we go. So what was that? Now you should be able to do number 3, 4. Number 13 is the next one. I'll skip quite a bit. Same thing I did last time. I skipped over 9 through 12, and that's because 9 through 12 are just an easier version of 13. The 13 are giving me vertices and foci. Now, vertices and covertices sometimes have nice, pretty whole numbers in there. Foci almost never does. It pretty much always is going to have some kind of square root. It's good because it makes it easier to figure out what our numbers are. So let's look at foci. Foci works just like vertices. So we say which value is changing. Well, I can do vertices or foci for this. I can say, oh, the x values are changing. So if the x values are changing, it must be horizontal. Well, notice the foci is h plus or minus c comma k. There's my h plus or minus c, h plus c, h minus c. There's my k. Okay. I can see that same k value in vertices, but the h would be harder to figure out from vertices. That's why it's nice to have a foci here. All right. So next, I have h, I have k. I can get a from the vertices. So remember, my center, we just found our center, is -9 because it's h, comma, -3 because it's k. Well, our vertices are how far it is from the center, and it's a units. So how far is it from the center to my vertices? So if I go from that value to -18, or if I go from that value to 0, that's a. Well, from -9 to 0, or from -9 to 18, how far did you travel? Well, you traveled 9 units. Okay. Well, right there, we already have almost all of my answer. So let's go ahead and write out what we have. We know x minus 8 over plus 9 over a squared, so b1, y minus -3 plus 3. Or, let's see here. We don't know what b is yet. We'll figure it out. The second equals 1. So there we go. We have almost everything to our answer. Here's the last part of this. Or the formula we haven't gotten to yet. It's right here. A squared equals b squared plus c squared. I know that's almost the Pythagorean theorem, but not quite. A squared equals b squared plus c squared. So let's see what we know. We already know what a squared is. A is 9, so a squared should be 1, not 18. You don't know what b squared is. That's what we're trying to find. We do know what c is. We can use that to find c squared. So there's our c value. So if I square that, let's see here, 6 square root of 2 squared, I square root of 6, I get 36. If I square the square root of 2, I get 2. And 36 times 2 is 72. All right, so c squared is 72. Now I just need to solve that for b squared. Minus 72. 72, and I'm getting b squared. B squared is, put that number there. Notice I'm not taking the square root to find out what b is because I don't care what b is. I wanted b squared. And there is my answer. All right, I'm running out of time. So that was number 13. Go ahead and try 14. I'm going to put the answer up. I don't have time to work that because I still need to do number 17 as well. And then numbers 9 through 12 are really just like this, except the center is the origin. All right, so pause the video, try number 14, and put the answer up in 3, 2, 1. All right, there's your answer for number 14. Notice the bigger number, the 49, the bigger denominator, is under the y, so this one was vertical. Okay, so we're going to skip ahead to number 17. Number 17. Let's go to, only number 18, just because this one's not horizontal, this one's vertical. So we're doing a lot of horizontals. All right, so this one right here, our foci. Here's our H, K, and C. H, K, and C. So our center is -3, 8. And I know that C is squared below. All right. Now, say which one it is, the vertical or horizontal. I said that I'm doing it because it's vertical. I know it's vertical because it's the y value that's changing for foci. Or if you want to get kind of tricky with it, you can say, oh, it's the x value that's changing for covertices, and I know that covertices are always backwards. You want to think about that, that will work. But I usually just look for either the foci or the vertices. If the y changing is vertical, if the x changing is horizontal. So I know here we're vertical. I'm going to go ahead and write out the answer, or at least what I found. I know this x minus -3, so x plus 3. No, it's y minus 8. We'll go ahead and circle it. All right, so next I need to find the b. The b is going to be from the vertices. Now it's the x value that's changing, so we're going to use the x value in the center and say, okay, how far is it from -3 to 2, or from -3 to -8, right? Both the same. The distance from -3 to 2 or -3 to 8 is b, and that is 5 units. So my b is 5, and 5 squared is 25. And now I can plug into our formula right here and say, okay, a squared, I don't know, trying to figure out, equals b squared. I have 25 plus c squared. Well, if I know c is square root of 11, so c squared is just 11. B squared is 25 plus 11, which is 30. And there we go. All done. All right, so those should help you finish everything else. I'm going to put the answer up to number 19 real quick, just so we can check out and make sure you're doing it right. Actually, I'll go back and do number 7. So skip number 7. I'll put the answer at 7. All right, you haven't tried number 17? Hit the pause button. You got about 3 seconds. And there's your answer. All right, let's see all we do great.